I'm Alan Johnston, KU2Y, and AMSAT's Vice President for Educational Relations. So you might have heard there's a new version of the AMSAT CubeSat simulator. So here is the original version. This particular frame was built by Pat Kilroy, N8 PK, and with the halogen lamp that we've been using. But this is the new version. So I'll tell you a little bit about what is new and different in this. This new hardware came about with some collaboration with Jim McLaughlin, KI6ZUM, and Dave White, WD6DRI. So thank you to them for all the effort that they've put in. So this new design is based on a couple of things. For one, we have new solar panels, which has enabled us to use a new frame. Basically, the solar panels are bigger, so we don't need 3D printed side panels. They're also higher powered as well. They are 5.5 volts, and they supply almost a watt of power, but they still cost only $2. So with these new high-powered solar panels, we're also using individual cell nickel metal hydride batteries. In this case, 3 cells with a nominal voltage of 4.5 volts. So that greatly simplifies the charging circuit. So here is the new board. So it still uses a Raspberry Pi 0W. Now though, we use the WH, so we just put a normal pin header on it. The older version, we had to put a stacking header on it. This is the new board, which is quite different. It's pretty high density. It has components on the top and on the bottom. Also, you notice the additional antenna options. This one has the dipole, and you can also use a monopole as well. You can still connect an SMA and put a rubber duck on there as well. So this new board uses the RPI TX library, which just uses the Raspberry Pi GPIO clock pin. And you notice it has an integrated bandpass filter there. In addition, you notice that the charging now is done through micro USB, so any standard Raspberry Pi power supply can be used. It has a built-in push button and also LEDs for transmit, power, and charging. So if you look at the board, you can see there is a battery charging board here and a 5-volt boost board here, and the other boards here, the 8 of them, are the current and voltage sense boards. So for each solar panel plus the battery and the 5-volt bus. So the net result is we have a lower cost board. We mount the battery using a stacking GPIO header, and that leaves room on top for this brand new STEM payload board, originally designed by Jim and David, and it has the STM32 Blue Pill Arduino compatible microcontroller there, which is a really nice really nice controller. In addition, it has the blue gyro board and the purple pressure, temperature, altitude board as well. So yeah, so that's basically it. The additional thing is we're now using an LED lamp for doing the simulations under illumination. And that's because now, using the FoxTelem software, we're sending voltage telemetry, and it turns out an LED lamp is good enough for activating the voltages. If you still want to activate the current telemetry, then you either need to upgrade the bulb here with a 9 or 10 watt LED lamp, or you can always go back to the original halogen lamp, or you can take it outside in the sun. That works really well as well. So that's basically it. So you can find information about the new CubeSatSim at CubeSatSim.org. Thank you very much. So now we're getting ready to launch the CubeSatSim. So I remove the remove before flight pin here. And since we're going to be flying it here, I'm going to flip it upside down. And we will be all set to go. Now, running FoxTelem here, and that will decode the telemetry once we start transmitting. So I have the other CubeSatSim frame here set up with the monopole antenna there. Okay, so right now we are in the audio frequency shift keying, basically the APRS mode that the simulator has done in the past. But next you're going to hear it doing its Fox emulation. So now it's doing the 200 bits per second data under voice. And we can also turn on the LED lamp here. And now if I pull up here, should be able to see some data samples. Next it's going to switch to the BPSK like HuskySat and yep, that's it there. Like HuskySat and soon to be Fox 1E. And if I switch to BPSK mode here, you can see there where the phasor diagram shows that it's working. All right, so let's see if we got some data. We only did a few frames, so we're not going to see too much here. But if I pull up data here and take a look at, for example, let's see, that one's not too interesting. There we go. There's a current from the battery being plotted there in data under voice mode. And if I switch here to, for example, temperature, and get the graph here in BPSK.